For thousands of years, humans looked up and saw a river of milk. We imagined a peaceful, static canopy of stars. But when the illusion of stillness tears away, we find a violent reality. The true story of our galaxy begins roughly 13.8 billion years ago. Swaths of hydrogen gas and dense clumps of invisible dark matter began to pull together under their own gravity, coalescing into the earliest protogalaxies. Fast forward to about 10 billion years ago, and our young galaxy experienced a massive, destructive event, a head-on collision with a smaller dwarf galaxy known as Gaia Enceladus. The Milky Way expanded by cannibalizing its neighbors. When Gaia Enceladus crashed into us, we absorbed its stars and structural material, creating our thick galactic disk. The impact compressed interstellar gas, sparking massive waves of new star formation. The calm night sky we admire is an optical illusion. We are living inside the surviving machinery of an ancient galactic-scale cannibal. This scale model shows the Milky Way stretches 200,000 light-years, but this glowing disk is a fraction. Zooming out, a massive, invisible spherical halo encloses it. Regular matter is a minority. 90% of the mass is invisible dark matter. Moving down from that dark matter halo into the galactic disk, we hit the dense spiral arms. Regions like the Scutum Centaurus and Perseus arms are packed with cosmic dust, acting as active nurseries for new stars. Hiding inside those arms is an extreme diversity of worlds. The trillions of planets scattered here, from scorching infernos of boiling lava to dense, waterlogged ocean planets. We cannot map these hidden structures with the naked eye. Astronomers rely on highly advanced observation technologies, like deep infrared sensors, to pierce through the thick galactic dust. To actually understand the Milky Way, we have to look past the glowing stars. It is the invisible scaffolding of dark matter that exerts the gravity needed to keep this rapidly spinning disk from tearing itself apart. Plunge into the center of that disk, and the quiet completely disappears. The galactic bulge is a chaotic, ancient environment, packed so densely with stars that their radiation blends into a single blinding glare. At the very core lies Sagittarius A star, a supermassive black hole anchoring the galaxy with a mass of 4.3 million suns. What we are seeing here is its accretion disk, a swirling ring of scorching hot gas spiraling into a pitch-black central void. The extreme gravity generated by this black hole dominates the region. It forces nearby stars to whip around the center at a measurable fraction of the speed of light. Fortunately, Earth is located 26,000 light-years away from that chaos, sitting safely out in the relatively sparse Orion Arm. But out here, we are still moving. The entire solar system is hurtling through space at 828,000 kilometers per hour. Even at that blistering speed, it takes us 230 million years to complete a single cosmic year around the galaxy. Orbiting 26,000 light-years out provides a critical safety buffer. Closer to the core, the extreme density of stars creates constant gravitational instability for planets, while the intense radiation flux from the bulge would sterilize any biological life before it could begin. That stable 230 million-year orbit we rely on has an expiration date. This trajectory map highlights an incoming threat. The Andromeda galaxy is rushing toward us at 100 kilometers per second. In 4.5 billion years, the boundaries will touch. Tremendous tidal forces will stretch their spiral arms into long tails, locking them into a massive cosmic dance. As the collision takes hold, supermassive black holes will merge. Colliding gas clouds will compress and ignite a massive burst of bright new star formation. For Earth, direct stellar collisions are highly unlikely due to the sheer emptiness of space. However, the gravitational disruption will fling our solar system into an entirely new, unpredictable orbit. When the dust finally settles, the Milky Way will cease to be a spiral galaxy entirely. The two structures will merge to be reborn as a single, massive elliptical galaxy, known as Milkomeda. The Milky Way exists as one stage in a cycle of cosmic recycling. This current structure is a temporary arrangement, destined to be rebuilt into something entirely new.